How do I
Isn't it?
ask?
Is it not on them? Oh, well, there you
No,
go.
it's not on the bottom panel. They hid it in the submenu. Okay. So I'm recording. This is, in theory, Coffee Compiler Club. Zoom has changed several things on the GUI for no good reason. They hid the record button. I had to go hunt it down. And of course, I'm recording every meeting, so I have to hunt it down now every time. And they changed all my panels from light to black with a helpful, very well hidden button that says change it back to white. It's like both of these things, like I can't see black on white text on black backgrounds. I just can't read it at all. So now go find the menu option when you can't read any of the menus. Here, they're all helpfully written in Latin. Go find the button that flips it from one color to from English to Latin or whatever. I mean, just come on, guys. What the heck you doing, Zoom? Okay, I'm done whining about Zoom. I'm recording everybody, obviously. We'll go put this up on live on YouTube at some point in the future. I don't otherwise have a set agenda. I have a tale to tell of interesting woe. Um, I'm on jury duty. Not even, I mean, I got past selection. I'm actually on jury duty. Um, it's safe to say that
Aren't you
this,
literally not allowed to talk about it?
I am literally allowed to say I'm on a jury. I can say mistakes were made here. But I can't say anything else till like the process is done. But then I'll have a tale to tell. It's pretty. It's not. No one got hurt, so that's good. Somewhere between scary hell and amusing. Um, that's eating up my week. Back to computers. Somehow I vibe coded my first like serious thing, and I don't know what vibe coding means here. I spent 10 minutes asking Claude or IntelliJ's Junie, whatever. It's the same, backed by the same engine, to go write me a search path for symbols for simple. So I have to do recursive directory searches. I have to do crack peek open ELF files, which I actually didn't get to. And if I find a file, it produces more symbols. I have to recursively go ask again for the next set of symbols from the last set. So it's not entirely trivial, but it's not a big deal. Um, yeah, the AI got close enough. And then I went and finished out the job. I think I went back to the AI and asked it a question or two more about cleanup things, and he had some useful suggestions. So I don't know. I claim I vibe coded, I guess. It seemed to
So
have worked. Now, was it faster than me writing everything from scratch? Not entirely certain. There's this thing where if it appears to work, you walk away from it. If you intend to expand and or do maintenance on it, you have to know what the hell was done. So you have to still ingest in your brain all the things that are the interesting invariants in the setup. And that's when you
I do
discover
not
that
like the it appears to work thing. Like
exactly.
I will not let AI write production code for me. I happily let it write tests
Okay.
and give me
Okay.
suggestions, but like it's it feels like there's a line that's way too easy to cross where
Yeah.
you trust it
Yeah.
and you really
Yeah. It,
shouldn't.
it's
And
really
I keep
good
fighting to
at
keep myself from trusting it.
it's really good at spamming the test. At whatever you call the teaching the test. It will pass the test, but it will not pass the next test because it only worked toward the one. Yeah, I had to go through, and it's pretty clear that he gave lip service to the concepts and didn't actually follow through. And so there were fundamental mistakes. They weren't bad. I had to, I got recursive things, so I have to shove things up and below the recursion barriers to sort it out. So it wasn't terrible, but I had to understand what was being done entirely. And in my head, I had this vision of how the recursion is going to go. He slaps down something that looks like a recursive answer, and he's blown it a few times. Yeah, reward hacking, Matt. Yes, exactly in the chat there, 100%. So yeah, I got my first code review of my, double X speed interpreter from Claude, who, was looking through and giving me it's everything you ever thought somebody got ridiculously taught in college for the best practices coming back at you. And of course, he's just wrong in some cases, completely misses the point in most cases. Yeah, exactly, Vivo. It's just like completely like, come on, guys.
But it
And
probably found one or two things,
And
right?
yeah, right. And then he found one or two things. And I'll have to go back and look. Like I took some null pointer checks out in places that were in my face and I was trying to get through. And having settled out and got the system done, I might no longer have a null there. And it could be I could go back to saying not null. That kind of thing going on. Uh, Fine. There was an existing large heavy API. It was very anti-performance design. I had to crack open a bunch of private things and get at the internal fields or replace larger chunks. Like I could use this if I just get at the private field. So I made it public. And then, Claude comes along and says, "You made this field public." Yes, I did. But you should make it not public. Okay, by cloning everything. That's his suggestion. Make it two entire giant, here's 100,000 lines of code. Make another 100,000 lines where one has a public versus private, and then we'll have it separate. It's just like, fine.
I don't know how often it backfires, but people have like copy paste text files that they use to say, don't suggest this thing, don't suggest that sort of thing.
Right, right. I need to go get my own version of that going for people who review my code. So here is Matt. I have to go drill on this one, Matt. A field guide to reward hacking in AI kernel generation. Oh my God. Uh-huh.
It's pretty entertaining, actually, because if you ask it to optimize a kernel, it will do all kinds of reward hacking. Like it will, for example, pre-compute the results in the setup hardest code. It's going to cache them, and then it's just going to reuse the results in the timed region. And that's just really one of the many examples of optimizations.
Okay. I'm gonna move this one over and haul it to the shared. See if I can get it here. No. See, everyone's got their own special sauce on how to move windows. Okay. And let me hit the share button. Okay, reward hacking up here. Field guide to reward hacking. 3 categories. Timing attacks. The kernel correctly computes but manipulates the clock. Holy fuck, really? I have the world's fastest, linear regression, logistic regression. I I start and stop the clock, and then I do the computation, and then I report the time the clock was started and stopped. The measured time is fake. Wow. I'm not certain to be impressed or stupefied. I guess I'm a little both. Like, surely, where did they learn this? Who else was
This is
hacking
the
the clock?
AI fake to the clock.
Yeah, that's what I'm reading this as. The AI fakes the clock. This is a reward
I guess
hack.
it met its goal. We need to minimize this number.
Yeah. Uh-huh. Semantic attacks doesn't do the right thing. Yeah, right. Yeah, I had did the wrong thing. Right. Call the built-in matmul benchmark instead of writing a matmul benchmark. Uh-huh. Okay. Okay. So this one is timing a little more subtle. They have two different computers, two different CPUs. One's the GPU, and they're timing on the CPU. Right. Yeah, there need to be some serious wall clock timing. And then a thread injection. Right. I time the foreground thread. I do the work in a background thread. Okay, okay. I have to go. Okay. I should stop. Oh, no, I have to go the most brazen
That
approach.
evaluation is actually amazing.
Oh, your
Read
sound broke up. Darn it.
Take a look at the description of this lazy evaluation. I love this one. It's also cool.
Just patch the clock to return 0.001, 0.0. Just really? Okay, fine. So let's try to fix your audio because I want to hear what you had to say there. So say it again. See if I get it this time.
Try now. Any
Yeah.
better?
Yeah, better. Yeah.
Interesting. So the lazy evaluation is interesting because it's just gonna do the computation in the equality. Just do the big thing. Kernel returns a tensor subclass that stores the input. Tensor doesn't compute anything, but the math what happens when the correctness check calls equality comparison on the result. So it just overloads the equality comparison it's debatable in that quality comparison.
The correctness check takes a long time.
That's
And
really creative reward
wow.
hacking.
Wow, okay, okay. I mean, yeah, hacking the test. Absolutely. They are hacking the test here. Fascinating. Let's see if I can I wonder if I can share without exposing things. I probably can't. It's going to show my Claude report here. Um and of course they always end up in these summaries, which and if you do these things, you too will be able to hack GitHub for fun and profit or whatever. The end of this really upbeat thing. Yeah, okay, there's a whole lot of replicate code here. Um, I don't know. But okay, so I won't put this up on the video. It's got too many baked in names. But the gist of the the code review is what I was just saying earlier. There are things that were had to be done for performance that it was commenting on. There are things that were I changed classes because the old classes were hardwired to do a bad thing, and I have a new class that has new interfaces in there. Well, if you pass the old class into the new code, it'll in fact throw a class cast exception and die. I'm like, yes, that's true. Don't do that. Fine. Okay, fine. Yeah. Yes. All right, that was probably everything there. Oh, like the simple hack. It's not worth looking at though. It's just too easy. Um, and it's too long and too easy, if that makes sense. So that was fun. I did it. I did the AI thing. I'll probably end up doing more and more of it for simple. There's a lot of things like simple is asking for trouble or asking for it because it wants to be kind of closely to what you're going to get taught in school, so it doesn't blow your mind or whatever. It doesn't disturb people's common thinkings too much. And then there's a lot of replication because each chapter builds on the last, but has all the code from the prior except where it has to be changed. That in turn means there's bugs in later chapters that get backpatched to earlier chapters or missed or not or whatever. And so there's a whole lot of consistency things I think an AI would be good at here. So I think, in the some future world order when I'm not drowning under jury duty and new job of things, I'll apply AI to the simple thing and see if I can have it clean out some of the earlier chapters into the later ones. And chapter 25 is still hanging out there for me integrating my brand new search into the existing mechanism. I'm up to the point where I'm asking the search guy to go pull up the pieces parts, and I didn't have that search laid out well and the simple, and so I AI'd my way to it, and now I have to go finish the integration there. Yeah, I see you yawning there, Tior.
Yeah. No.
And otherwise nothing. It got hot. Summer's here. I need to do a burn pile. I'm going to go to Seattle to talk to Hashgraph people. I got like three other things, and then jury duty piled in. It's fine. Anyone else? Something? We're all done here. Levo, do you want to talk about anything? Because I'm not certain where you're at.
Not really. Well, related to AI, I noticed that it's very handy to have AI like figure out what the parameters of. For command line applications, is very good at like taking whatever I'm trying to do and then just telling me what command line arguments I want for that script. So I found it very useful if I just like want to um, like just write a simple script, a bash script file, and
Shell script
with
hacking.
like awk or a tool that I don't use every day, and then
Right.
just you can't really mess up the arguments. It's like it either tells you the correct argument or it doesn't, and like there's no bugs I have to like figure out, and the AI is pretty good at that.
So it's a one-off, one-shot, quickie shell
Yeah.
scripts. Like I would write them all the time as little things.
RM-RF
Yeah, exactly.
slash.
Well, that's the Amazon how to repair your data center bug, right?
The other
Wow.
thing I would mention was, but Aaron's not here. I started using his no commits technique. So I accidentally forgot to re-enable a test because the thing I was like fixing took more than one sitting, and I thought I enabled it, did not. And I'm like, oh, I'm just going to use no commits. And then it turned out to be very handy.
What was the hack? No commit?
Yeah. So what he said was he had a Git hook that if grep found no commits in your source file, it would just reject it.
That
And
technique is so in Jonathan Blow a few years, maybe 2-3 years back, he was using that no checkin, that comment, and a pre-hook, and
I'm missing something.
the GitHub has a pre-hook script that it will execute. So you comment your code, leave a comment, no checkin, and while you commit, it checks. It runs against that pre-hook, and if it finds no commit as a comment, it doesn't allow you to commit. So
so you can force a file to not commit accidentally.
Yeah, the hooks you can. It's just like run this script as part of the commit pipeline. So it's like check for anything.
Oh, right.
Injection into GitHub.
Yeah, I forgot to mention what Git pre-commit hooks are, but the one that I actually got started as it wasn't really no commit. What I did was I have a directory full of tests, and only in that directory, if I have //brb, it doesn't matter if there's a lot of white spaces or none. If it sees //brb in any test file, it will just say not committing because you forgot to like fix that.
What does BRB stand for? Be right back.
Yeah. So I'm meant to do it like before I walk away from the computer, but sometimes stuff happens, you just forget.
So you've turned off a test so you can get past some point. You want to turn back on the test at some future date.
Yeah. So I initially started using that as as my pre-commit hook, and it's actually really handy.
Okay.
I would be tempted to argue it should be to-dos.
Yeah,
I guess we do check to-dos in. This always seems odd to me.
Oh, I see. When I'm doing a large project like this one here, this thing I did for Hashgraph, it's a couple months. I have a lot of pieces that I know I need to get handled eventually. They're not handled yet. I don't even have a test case that'll hit them yet. That's a to-do. That's a, hey.
Yeah. In the early stages of a project, that makes sense. It's like when the main line is not the release branch,
right?
Okay, nothing matters.
Right. And now I'm headed for the release branch, and people are saying, you got some to-dos in here. And I'm like, that means your test cases can't hit these points. And therefore, your tests are incomplete, or there's some hidden invariant that says you can never get here, and that should be an assert instead.
That's actually a good point. At which point because you don't know it's going to work, so you leave lots and lots and stuff and continue to pile on. At what point you hit the stop button and start restructuring things that more and more into shape? Because when I observe, at least in my work, I always do the same thing. And when there is a certain point when you progress that too much and it becomes too painful to change back things in order to restructure them. So where for all of us, where do we draw the line for
right.
that when it's
when do you declare the old stuff is dead? Yeah. Half of the review I got from Claude here was, if you use old stuff to call new stuff or new stuff to call old stuff, it'll break. And I'm like, yes, don't do that.
Yeah, I had a lot of issues with Claude recently when I was doing my work on hash maps. I mentioned a couple calls ago, and I was having to analyze the new code. And I'm like, I was only working on get input, and I let everything else break. But it was like, it was so freaking. I was like, your iterators don't work anymore. I'm like, I don't care about my iterators right now. I'm like, what do I have to do? Just analyze this.
Yes. I'm still curious to know what you did or what whatever JC Tools did that got non-blocking hash map to be so much slower, because that's so like I
did look a little bit more after our last call, and I didn't look to figure out why non-blocking hash map was slower on gets. I'm pretty sure it's because of the indirection to the interarray managing hash codes. Like, that makes sense. But the good thing is, you kick the crap out of concurrent hash map on mutating operations, because it still freaking uses synchronized. and synchronized got expensive in like Java 15. So you're like,
what? Okay.
Yeah, they got rid of bias locking. So synchronized is a real. You got a CAS on each end of that thing now.
Well, why? Okay.
I
Why did they get rid of bias locking?
I assume they got rid of bias locking as part of the move to virtual threads in Loom, but I don't know why. It upset me quite a bit. Like bias locking was so cool, but like there was a period of time of about 4 years or so where like synchronized was considered just like
free.
Don't use it anymore. And like now with Java 25, it's like, yeah, you can use it again. So I don't know, maybe they'll bring bias locking back, but I kind of doubt it.
Okay. Interesting.
But for whatever reason, concurrent hash map still uses synchronized.
Yeah.
But whatever, like uncontended synchronized is still really expensive. So non-blocking hash map, I forget, you're like 5 or 6 times faster, maybe more. It was beautiful.
I knew I was faster on writes almost always, but I was tight on reads forever and a day. And the hash map is the hash code is one more indirection, but maybe that's enough.
Yeah, I wasn't working with, I think my smallest data set was 1,000 key value pairs, which I would think you shouldn't be hurt by it there.
No, because it should sit in your L1.
Yeah, but it's all like the extra 3 operations to go over there and get it and compare when like with like concurrent hash map basically looks just like hash map. And if you're the first entry in the bucket, everything's great.
Yeah, you win. So there's no
Yeah.
If there's no
and so I was writing this like compact hash map and trying to use way less memory than Java util hash map.
Right.
And which was fairly easy because Java util hash map is horrific.
Yeah.
Right. But like, and I wanted performance parity. So I was fighting all the same things I think that were hitting non-blocking hash map.
Yeah.
And it's just like, it's like very hard. But I managed to achieve parity while still having like half the memory.
In the realm of the non-blocking hash map long, where the key is a long, you can get the hash from the key sort of trivially, so you don't have to cache the hash.
Yes.
And that saves a whole nother indirection. But otherwise, in a Java array, if I have a key object and a value object, I cannot have an int hash because that would mix ints and objects. And so you must be on another cache line.
Yeah. Yeah. So painful. So like some of the stuff I did is like I did a mix of open and closed addressing. So when you don't have a collision, you're like open addressing, and your key and value live in the table. When you have your first collision, you probe 1 forward, you store it there. When you have your second collision, you unwind that and form a chain, but you put the hash codes in the same object as the key and value references. And then when your chain gets longer, you go to arrays.
You can unwind atomically, or you're not.
I'm not. I'm competing with Java util hash map. No thread safety here.
Okay.
Which is like, I very much like,
what the hell?
Like it would be fun to do the concurrent one, but so much is not concurrent.
Right. No, if you drop the concurrency issue, there are other things.
Yeah. There's like, there's a lot of things you can do. Like, this is fun. So actually then I'll dovetail a couple of things together here as we've had our AI conversation and then the things you can't do in Java conversation. I'm changing jobs now, and I'm going to OpenAI to work on Python backend performance. So I'm going to be programming in C for the first time in decade plus, and thinking about all those fun things like no object headers and no rules as to what can sit next.
Has changed.
Python has been written in. Python's written in C, so I'm very, very glad I don't have to deal with C++.
Well, you're not writing. You're writing Python, and you'll write to whatever drives the GPUs, which will be C or CUDA or whatever.
I'm going to be working on the Python backend in C, the Python runtime. I don't know. I mean, I'll probably be working all over the place.
Yeah,
but
then you probably will be C. Yeah, the C++. I had this giant whine, 6 months ago about it for modular, and I'll claim it again. They kind of screwed themselves up in a big way. Some bad intersection of you can't debug or you can't have optimization. You have to pick one or the other, either optimize or debug. But as soon as you have a bug in optimized code, you're SOL.
That's been true with C++ for forever. I mean,
not forever.
Last time I did big C++ was 15 years ago.
Because when I was doing Hotspot, it was C++, the very early versions of it, and that was not an issue. The difference between debuggable and
was it just that it wasn't very optimized?
I'm sorry?
Was it just that the optimized wasn't very optimized?
No, the thin layers, the million thin layers that C++ now semantically does didn't appear back then. There was a much more direct mapping between the code you wrote and the code that got emitted. And so the way the wrappers work in debug mode is they just pick another function call and just another, just another, just another. And you're 10 layers deep. And so the debug mode is now 10x slower than optimized. So it used to be the case it was 2x slower than optimized. Now it's 10x slower than optimized. And these are like round numbers. It's worse than that even. But it means that if you have any sort of timing sensitive thing and you switch to debug mode, not only is it take you forever to get there, like you go get coffee, it's time to go to lunch. It likely just doesn't show because you're just too slow.
I was dealing with something like that in Java recently, and so curious you're taking it. So again, hash map stuff, right? And I was performance testing, and I was doing, I think, gets, and my keys are strings. I wanted like a reasonable hash code, and it was showing that string.hashcode was actually like high on my profiling list, but I had gone out of my way. Like all my strings were cached. Like there was no strings being produced. String has a cached hash code, and my flame graphs were showing like string.hashcode goes into like Latin1.hashcode. Like that path, according to the code, is not possible once you've computed the hash code once. And in the debugger, it never went there. But in non-debug runs, flame graphs said I was ending up there. And I'm like, what?
Oh, really?
Yeah, I was wondering, like, are small strings like intrinsified and they don't bother to make objects, maybe? In the end, I kind of just decided the flame graphs are probably just wrong. But it didn't feel but still, they had to pull this information from somewhere. Like, where do they randomly pull string hash code from inside of a get function? Like,
somebody grabs a bunch of PCs and interpolates the PC against it depends on your profiling technique. But if you're interpolating PCs between safe points, then somebody comes through and says, well, I had a safe point, and I had a safe point. This one says I was some way in between the two. I'm looking at the bytecodes now. I don't know what the JIT did, and I'm trying to guess where you landed. And I see a virtual call to the encoding rules. And secretly under the hood, the hotspot, the JIT said, no fucking way. This never goes that way. We'll test it once somewhere else and never again, right? And we'll hardwire in the correct thing. And the other guy's saying, well, there's a virtual call to ISO character encoding, blah, blah, blah. Maybe that's where the bits are, and when the time goes. I mean, I'm guessing what goes on with the flame graph depends on your profile technique.
Yeah, this is async profiler, which doesn't have the whole safe point biasing problem.
Yeah, it has.
But in the end, I went and switched to big I integer keys, which clearly do not have this problem, and performance didn't change. So it made me pretty confident that the flame graphs are wrong.
Yeah, that async profiler has this very problem.
I thought it avoided it because it doesn't have the safe point bias.
No, there's two problems, right? The one is the safe point bias. You don't get them where you care. Okay. The other one is I don't have an exact Java. There is no Java semantic point where this PC relates to.
Oh, okay.
So he interpolates. I have a safe point here. I have a safe point there. I landed in between the two. Okay, what code am I executing in here? Well, that's all about what the JIT did in between those two safe points. What the JIT do? Well, he doesn't have any clue. So he has to go make a guess. I'm going to guess that if I read these bytecodes, you make a virtual call to ISO character encoding, yada, blah, blah. No. The JIT said,
okay,
done. And then, so you get bits in the wrong places. Just me guessing. That's highly theoretical.
That sounds reasonable. But regardless, I am very much going to miss working in Java, despite that.
Yeah, boy, I have to say C++ I did not, but I might be interested in doing C again someday.
Yeah, that was exactly my thinking. I had said no to C++ a few years ago for a job, but I'm like, C, that hasn't changed since forever. Like, it's nice and simple.
Right. I think they picked up some reasonable things like / comments, and you can declare variables in the middle of things and not all at the start of the
yeah.
Something.
I mean, the last time I did see it did give you all those things.
Sort of, nice.
Yeah, it's not like the original KNR where everything is weird.
It does have the auto keyword nowadays, but it's a little bit more restricted, just for local variables, basically.
But you do have an auto keyword.
Yeah, but it's quite
as long as there's no templates or operator overloading, I think sanity can remain.
There is something like function overloading if you use the generic feature. it's used for mathematical functions. For example, like if you want to just have sine function that works on double and floats, you can do that in C now with this underscore generic. Something pretty odd. I think it's C11.
I have to go look. Okay. I don't know. Let us know.
I can handle. I can handle that.
Yeah. Exactly. Yes, the whole templates as a Turing complete programming language.
But so instead, I'm trying to now like wrap my head around. I don't know Python, and I'm trying to wrap my head around what Python does, and it's
not
it's
terrible.
it's pretty, but also pretty scary. Like tying right back into the hash maps. Like every object is a hash map. Every field is a hash lookup.
JavaScript, Python.
Yeah,
everything's a hash
I think
map.
I have something to work on day one.
Yeah. And performance is bad, so switch to C. It's an interesting trade-off.
And that part pains me as I look because I was looking at like PyPy, which has amazing performance, but it doesn't work with most of the Python extensions because it can't call out to just random C code. And it's sad. So it's like it forces everyone to do the interesting work in C instead of this beautiful language that they love. So
it's not the trade-off I would make. Like I said, it's an interesting trade-off. Now it's a long time. Like 20 years ago, I went to the Python community and said, I can do for you what I did for Java. And they were like, nah, we're good. And I was like, okay, fine.
Well, if you change your mind, let me know. I know a guy.
You got money? This would be a very entertaining, long desired project for me. I would be happy to do it. But, someone's got to pay my bills. So
it's OpenAI. They've got money.
Yeah, but are they interested in well, they might be. I was figuring for the AI companies that somebody would pile in and say, come do a different AI language than CUDA that does something good with GPU. No. Faster Python, please. Yeah, okay, fine. And then, like I said,
so I'm going out to San Francisco in 2 weeks to start. So if you want to meet up, we can talk.
Well, put me on your calendar. See if I can do. When are you going to San Francisco? You want to do that?
The first week of April. So week after next.
Yeah, shoot me a mail and let's just at minimum let's go have dinner, lunch.
Yeah, I won't know. It'll be whatever day 3. I won't know anything, but at least it'll be fun.
Yeah, are you out for more than a day?
No, yeah, I'm out for that whole week.
The whole week? Yeah. Okay. Let's. Is your wife coming? Can we go?
Nope. Just me.
Okay.
To her chagrin.
I have to bring my wife. She'd love to go, but not to sit with a bunch of computer geeks. Geeking. So, fine.
What's funny to me now that Cliff mentioned Python, it seems to me that in AI, actually no one in the AI space is using Python. What people use instead is PyTorch, Triton, Gluon, TSL, TLX, Palas, JATS, and I think I could keep going for a while. And they are really different. Like even integer, like if you think about the numeric promotions, what happens if I add float 32 to int64? The answer is different depending whether you use PyTorch, whether you use JATS, or whether you use CPython with NumPy library. All of them have different promotion rules. So they're really completely different DSLs.
Like way back in the 60s, not 60s, 70s and 80s, everyone on the planet was producing new chips. Every chip was different. People were trying their best to explore the space and come up with all kind of weird-ass possible things. And I was writing compilers.
Your math is different from my math.
The other side of it. And then everything died. Of course, it's all x86 or ARM or RISC or whatever, R5 now. This one feels like the languages for the GPUs feel like to me. Like we're just exploding every paradigm on the planet. Fine. Yeah, I can be bought. I'm a little more expensive, but
Once upon a time, I wanted to write a faster C++ compiler, and I tried to talk to a couple of people about it. It did not go well. Everyone wants someone else to do it.
That's another one. I'd be willing to do a fast optimizer for C++ if somebody else does the front end. I am not touching.
Oh, that's what I wanted to do, the front end, because I know I can destroy it.
Okay, well, but see, now somebody has to fund it because I know you ain't got any money.
Yeah,
I got no money because I ain't got any money.
I tried talking to Adobe. I knew someone Apple, but I knew Apple wouldn't go
Oh
for
my
it.
God. Oh my God. Okay, here's the right paradigm. I went to Apple to interview for, a year ago when I was looking for a job sort of actively. I went to go interview. They asked me basic, fundamental, intern level programming questions. And I'm like, Gordon Ramsay, please can you prove you're a chef by boiling an egg?
Did they not know who you were?
Yeah, I couldn't believe. The guys who interviewed me couldn't even understand the concerns I was having about the code in question. Like they're just so far down there. I was just like, oh God, guys. So that was, Apple was a hard pass on me. Wow. What the hell, Apple? Fine. I would have come piled in on their AI chip. There was smart engineers around because at least one of them was like, come work for Apple and save us. But the people who ended up interviewing me, they had no clue what they were doing.
I had that
Have I ever
experience
told you
at
Google's
Google.
story of that style of tragedy?
I'm sorry?
Google's story that fits like that tragedy is the guy who maintains Brew interviewed at Google to be on the Mac tooling team.
Seems like a reasonable choice.
And they asked him to reverse a linked list in an efficient way. And he was like, I don't remember my data structures class, and gave some terrible answer because he had not efficiently needed to reverse a linked list
Yeah,
in a
right.
while.
Yeah.
And they passed on him. And he was like, you do realize literally every developer in your entire company is running my code on their MacBooks.
Apparently not.
And they were
Wait,
just like,
Brew?
right, but can you reverse a linked list? And
We don't use Brew.
couldn't get out of its own process to not trip over their feet.
We
Yeah.
don't. I don't think we use Brew, do we?
Oh, I'll bet you not only do they use Brew,
Brew
but
Brew is
somebody's got a
not
tracking going on and
installed.
they can tell
No,
you
it
just
is
how
not
many people call
installed.
Brew, how often every day, and I bet you it's a big number.
No, Brew's not
Even
Apple
though
installed.
might be the one place that doesn't use Brew.
Google, you
Yeah, we
don't
don't.
think
Oh,
that
oh,
everybody
Google. I would think, yeah. Sorry, I was
everyone
thinking
We
uses
do.
Apple.
We do. I am looking at it, and we don't have Brew. I'm opening my work laptop now. It
okay, I
is.
hear you say you don't have Brew, but are you telling me that there are no developers who are sidestepping process in order to get a job done and they just grab Brew because that's the quickest way to get the job done?
Uh,
This is a number that you
Policy
cannot
on.
report.
Yeah,
You do not have
you're
this
not
number.
supposed to. You're supposed to use what's it called? Mule.
Yeah, right.
We
You're
have.
supposed to use, and then shit didn't work. So what I did do was grab the tooling that worked.
Yeah, so
You know,
we have a package manager called Mule, so you're not
right,
supposed to use Brew.
right. We have a globally glorified corporate answer that you're supposed to do, and some big
Yeah, and
project
is it an
use it.
in-house developed answer?
Google has some
Yeah.
good in-house tools, but I'll just bet you people grab Brew on a daily, every day big, and I bet you that number is
Brew is
keeping coming.
blocked. You have to get an exception to opt out of something called Santa because it blocks random programs from running. You have to get an exception to run Brew.
I'll bet you that there's a lot of that. I
There
certainly have
isn't
had
because
companies tell me I can't do X, Y, or Z, and I'm like, you want me to get my job done or not? And they're like, yeah, okay, give me the exception, okay, and done it.
Aaron, the story I heard was the Brew developer couldn't what was it, reverse the linked list, or I mean binary tree.
Yeah,
I heard that
whatever.
he couldn't. I don't know.
It's the
I
wrong.
don't
It
know
may
how
have
did
been
you
a
get it.
binary tree. The
It's
details are
the
not important part of the
wrong.
story.
It's the wrong question to ask. Does that not make sense?
Because when I saw the question, like I just like didn't even think about it. Like I had no idea what it was or what it meant. But like a year ago, someone showed it to me, and basically what they wanted, basically the question is, you have a tree, uh, exchange left and right with each other, and do that for every element in the tree. And I'm like, is that supposed to be hard? Like I'm like,
No,
I did it in 10
the
seconds.
wrong this is the wrong question, wrong way to view the problem. Here's a guy who clearly has done lots of cool things, and he sits down at his desk and he comes up with Brew and he makes it work and he gets it widely used and whatever it's going to be. C2, that there are many people who've done really cool things that require deep internal thinking. Okay, now separately, I want you to stand there in your kitchen and boil an egg while I'm screaming at you that you have to do it in 15 minutes or less and hurry up and goddamn get this thing done. You
Yeah.
can't perform under those kind of situations.
Coding
That's not your
interviews
skill set.
we do coding interviews just like so wrong in our industry.
Yeah.
Like it is horrible, and I conduct them all the time. I try to do it different than like the corporate prescribed procedure, but still I feel so bad. And like, sometimes I have to do this like to managers. I'm like, I have no idea why I'm having a manager do coding, but here we go. And the one that I've liked the most, the style, is take home assignments. Like give me a problem, make it much harder than what you would give me on a whiteboard or in 45 minutes.
Right.
Give me a week to do it, and then have me walk you through the solution. Like that of anything seems reasonable. But then again, the person that does brew or cliff click shouldn't be given a coding interview at all. Like that's just silly.
It's there. So some years ago, when I was doing interviews for startups to hire people, I suddenly realized this very problem that here is a senior guy who's done really good work, and he was having trouble doing some sort of binary task with bit fiddly things. And I was suddenly like, this guy could do it if he had calm and quiet and peace, but it also doesn't, that's not the skill I want out of him. That's not what I'm looking for. Why the hell is this a question you need to ask? So I promptly aborted that particular, mission, and I went to a different direction. And every interview after that was broken out into the guy was excited and wanted to work. So I was looking for enthusiasm because that would just be the number one driver. If you're excited, you will make it work. And then I was looking for, can you do something? So either show me a project that you did or take home a coding project that you had a week to do. And it wasn't terrible. You don't have to spend all your day at it, but it'd probably take you a couple hours. Give me what you're doing with it.
I think part of it though is that like big companies like this, they want people that can build things from first principles and not, just like a lot of these libraries are or projects are built using other libraries that exist. And so just because you can build a project doesn't mean you can build it from scratch, right? You may need these people may be building things, but using a bunch of libraries and code that already exists. And Google
my experience has been that that's what companies want. Like exactly. I get shit for building from first principles.
I'm going to use the JRE.
Yeah,
right Java, I'm going to use the JRE. I'm going to use the JDK. Sorry, the JDK. I'm going to use the library. We're going to use the libraries. Of course.
Google builds everything from scratch. Like not like you'll be using libraries, but they're made internally at Google. They're not like open source for the most part.
It's not. Yeah.
I think the fundamental thing was the setting is wrong, right? Time limited with someone watching over you, and that's like having limited tooling. Like I'm amazed that now we actually get an IDE to do coding interviews in. Like it's an online IDE. There's no debugger, but like my God, I can see if it compiles and runs. But it's still like everything is wrong. Like this is just not how you function.
That's realistic though, because like I've been on teams where I can't get a debugger onto the system because the code runs on a server in a cloud, and you can't run the debugger. So you need to be able to think without a debugger sometimes.
No, and I think that is a fault of the system that's trying to set up and run that system. I have certainly run production systems where shit's in the cloud, and the sort of the number one thing is, it works on my desk, it works for me, and of course it fails. So now I have to fucking debug the cloud server. And if you deny yourself tooling, it's like you're shooting yourself in the foot. What the fuck? Oh, there's no debugger? Well, fucking put a debugger on it. You can open a port for the debugger? Okay, open a port for the debugger. Jeez.
You can't do that because no persons are allowed on the production servers.
I've been fighting with that with heap dumps. Like we're having out of memory errors. Like, all right, let's get a heap dump. All right, we have the heap dump. Can I look at it? No. Well then, we're done here.
Yeah, exactly. I have a black box. It broke. Fix it.
We get a stack trace. That's about it.
No. Okay, I'm just saying, people do how they do it. But when I do this, and when I go debug other problems of my code in somebody else's setup, the answer is always, get me on it in the place of where it breaks with all my tools, or don't bother. And then at some point, some guy with big bucks says, okay, we'll trust this dude. Make it happen. And then the security guys say, okay. They open the door and you go fix it.
No, heap dump analysis is a problem when you have all this data that's not allowed to leave prod. So you have to do your heap dump analysis in a VM that's in prod.
That was never right. That's okay. I went into the system behind their firewall and I did my debugging there and I left the data there. Okay.
Yeah, but you
But
want
I
to bring a
had
heap
my
dump back to your
tooling.
laptop? No.
I'm sorry?
Yeah.
Say again, Aaron, I missed the
I
laptop
said,
part.
if you want to bring a heap dump back to your laptop, the answer is no.
I brought my tools to the heap dumps.
We not to name company,
Yeah.
are so restricted. Any command I want to run in production, like literally each command has to be approved by a peer, which made things like ls hard to run.
Uh-huh.
So I finally, for unnamed company, I found that we could upload and download files without permission. So I wrote a script, uploaded the script, got permission to run the script, and then I could change the script and upload it again, and the permissions held. So I was like, whatever I want to type in, put it in my script, upload it, run it.
Sounds
But
like
still, meaningful.
Microsoft, because like I used to work for Microsoft, and like they had like a lot of theoretical security, but there were so many like loopholes. It was very bad.
And if you didn't have those loopholes, you wouldn't be able to get shit done.
Yeah.
Those loopholes are
Yeah.
there for a reason.
Google doesn't have the same loophole that Microsoft does, and Google is working fine. I disagree. I think that like Google has built a lot of tooling and infrastructure around not having to have humans in production, and they have done an actually decent job of it, unlike Microsoft, which is like the trust model is different. Microsoft is like, okay, keep viruses off people's computers at any cost, and then Google's like, just don't trust humans at all. Require multiple people, make them check in code into the repo, and then let the code do whatever you want it to do. Multiple people review the code. They probably are not all infected with viruses.
I don't know. Yeah, maybe maybe Google's done some things right. So, and like I said, they have done some good stuff. They've also made some fine questionable choices elsewhere, but that's okay.
I can't
Yeah.
think of the last Google product I used, like Maps and
Google?
Google
Android.
Maps. Sorry, I use Google Maps and Google Search. Google Search, I have some good competitors for now. A lot of people spam Google Search, and I have good competitors on Google Search. But Google Maps, I still use all the time.
Google Search does not work. Like I just use one of the AIs. It will give me a link.
Yeah. Well, I commonly will go get the AI readout too. Like the first, 2 pages, I'll say sponsored of bullshit. Um, and many
So
of my searches have nothing where the auto hit for the sponsored ad is, Amazon will sell you a book on whatever, link lift reversal or something stupid. I'm like, no, give me the fucking 2 lines of code that does this.
So I used to use Gmail. That was invented 20 years ago. Android was probably 10, 15 years ago. I don't actually
You're not
remember.
using Android now?
No, I do use it, but it hasn't been written it wasn't invented in the last like 10, 15 years. So
No, that's true.
Android, Chrome, and Maps, they're all, and Gmail I used to use, all like 15 plus years ago. I can't think
So
of
you're
a
saying
single thing I
you don't use new Google stuff, or have you moved off all of those platforms?
No, I mean like there's none of their products I want to use except for maybe Maps.
Yeah, I use Maps. I use Docs sometimes for just like quick
Yeah, we're
writing. Like
using
if I want
Doc
to
right now.
professionally publish something, I'm gonna use Licks. But if I just want to take some notes and then not have to worry about where the file saves, I love Docs for that. And then I don't use Gmail. I use Proton Mail. But
Right. I might
I
switch.
I use Google Search all the time. Google
Right.
Search is
And I
still
don't use Docs for
amazing.
notes because they get lost as much as anything else. So I keep my notes in a place that's been around since computers have been around, and I'm not worried about them now.
/temp? Is that the
Yeah, something like that. You're close, but not temp.
I have too many
tilde
computers.
/temp?
I have too many computers because I'm on a MacBook now, but I've got this micro PC. It got the
No, your
the
AI is
framework.
filtering your PC out.
Yeah.
You have to hold it at your chest.
Oh,
Yeah.
there's a
Go.
trick
Oh,
to
that's
the
pretty.
AI.
Little tiny.
Yep.
Laptop handhelds. This you can hold this with
Yeah.
I got
I have the problem that I can't read those little things. So if I'm going to have something I can't read, it's going to be my phone.
framework 12.
Mm-hmm.
And then I got more. It's just there's ones that are over here.
Right. Or you have a
Like
giant monitor and a full-size desktop with everything on it and all that kind of
Yep,
stuff.
I got that too. And I've got 2 computers hooked up to that. I have my gaming desktop and I have my workstation.
There you
So I
go.
got the gaming desktop with Windows and like the 950 X3D, and then I got the gaming, or sorry, that's the gaming one, and then I've got the
Yep.
workstation with the Threadripper.
Oh, yeah, the Threadripper in there. Yeah, that's interesting.
Yeah, well, the workstation, yeah. So the workstation
Yeah,
is running, I think, Manjaro, and then
might upgrade my machine at some point. It was brand spanking new, top of the line 5, 6 years ago.
it's not a good idea to upgrade right now. I bought $1,700 of RAM for that when I built the workstation because I was going all out. That's now like $7,000 of RAM.
Oh
Yeah,
my gosh.
apparently Macs are now the budget PC. Like,
Really?
like because
Yeah.
they didn't jack up their prices because they secured all their RAM years ago or a year ago. So
I mean,
they're bang for the buck. They're the cheap computer now.
Wow. Okay.
yeah. For a workstation, Mac Studio is pretty decent, actually. Yeah, as per
I
price.
can't I can't
It's
use a
not
Mac.
it is not so good for CPU though, because like the Threadripper still has much more CPU power than a like Mac Studio. Even with
Sure.
M3 Max, it's not even close. Like Threadripper demolishes it by like double.
I can't use a Mac for the
But if you want
keystrokes
to
are
use
wrong, and I've tried.
the keystrokes are amazing. What are you talking about? I love
You
them.
you can install Windows on a Mac.
If I was to completely install Windows, that might work. I tried very hard to remap every possible thing to a Windows compatible layout, and I could not get it to go.
Just
Still
learn
working.
the Mac key layout. It's so much better. I use both of them all the time, and I did Mac one is completely superior.
Emacs is so much better than VI. I use them both all the time, and Emacs is the clear winner.
Okay, so
Only when used within Windows inside Cygwin.
maybe one of you guys can solve this problem. I have no idea how to do it. When I'm programming, if I'm on a Firefox or VS Code and I'm like typing something and I want to look up something on the man page, I can open up the terminal with a hotkey, but on the Mac, when I close the terminal, like with quit or Control D or whatever, it doesn't actually go back to the program I was using, like Firefox or
Oh, it
Code.
doesn't unwind the. Oh, interesting.
Yeah, it goes to Finder, and I'm like, what the hell? I want to type. Like, is there a way to fix that? Because I
Wait,
could not
wait.
if I open a terminal,
Wait. Let's not solve that one on Coffee Compiler Club. Coffees are compilers.
okay.
But that's
Yeah,
a
that's
Mac.
a
Ask it
little
on
too
the
far
Discord
from
channel.
programming. Yeah. Okay.
I feel like Brew gets
we
2
all
points for
actually
being
know the
both about
answer. We're just
compilers
refusing
and
to tell
coffee.
you.
I'm confident the answer is long and detailed and complicated and not rocket science. So we'll all get it, and it will be a very boring video for the next hour. Which maybe
you know what?
the correct answer, but I don't.
AI told me that it can't be done. You got to
There
do
you go.
something else.
And yeah, and Abraham Lincoln says, "Don't believe everything you read on the internet," too. So
Okay. So speaking of compilers, this is tangentially related, but the GraphViewer library that I have now has a separate debugger that is a separate process and can now load the graph dumps from the potentially from a compiler as a file. I can click open file and load it.
they're
So
fun to play with, graphical debugger things, but
yeah,
never made one useful in any sort of production debugging setup.
can I share my screen real quick? I'll show it.
Oh yeah,
Could I
knows
squeeze
everyone
in?
wants to have a I missed. Hang on.
Could I tell Aaron the no commit thing? It will be quick.
Oh yeah, sure. Okay, go on the share.
So Aaron, after you told me about no commit, I forgot to re-enable one of my test cases. So what I did was I had //brb. Whenever my test folder has //brb, it will refuse to commit, and I found that so handy.
You just wrote a Git hook for that?
Yeah. Just because of what you said 2 weeks ago or whenever you said it.
BRB?
My most useful Git hook that I've written is a pre-commit hook that greps the code that's about to be committed for / space no commit. And if I have a comment that says no commit, then it won't commit. And I find that incredibly useful when I'm like, oh, I need to do this thing, but I want to remember to undo it before I commit it.
Yeah, I thought, oh yeah, I probably won't need that, and then I forgot to re-enable the test case, and I'm like,
I
okay,
have two
this is
cases. I have a
pretty
no
good.
commit hook that checks and a no push hook that checks.
Okay, I'm going
Oh,
to whine
interesting.
about Zoom again. The share button has been buried 3 layers deep now. So try
Uh,
again, Ryan, to share. See what happens
Okay.
now.
Can I share my
I like it.
screen?
We're now just repeating the opening of Coffee Compiler Club all over again.
Yeah, yeah. Zoom,
Okay.
what the hell did you do? Why did you do it?
Yeah, okay. So you can see the viewer window now, right?
Yeah.
So I can click open file here. Go to my temp. Oh, they're gone. Hang on a second. That's because they're temp files.
Live
Okay.
demos every
All
time.
right. Hang on. I can regenerate them. Just run this real quick. And it should dump both of them, I believe. I should run that in release so it dumps it quicker. Is it worth recompiling?
No, do the demo or go set it up and then we'll try again. I'll unshare and reshare.
It doesn't take that long. It only takes like 5 seconds to run. 1, 2, if I run it in release anyway. 2, 3, 4. Okay, it's done. Now I just need to switch it back to debug so it's a little slower. I'm doing this on purpose. All right, so I got this debugger and I'm putting it in debug mode so you can see like the loading animation
No,
that I have.
I don't care.
Yeah, so I have these like graph dump files now. So I'm gonna open this file and I get this like loading, uh, opening, deserializing. It's
No,
gonna
it's
take a
not
second.
necessary to run slow here.
Well, it's just opening. It runs too fast if I don't do this. I guess I can do it. Hang on, I'll do the fast one. All right, I'll stop putting in release mode. Okay, so I'll open the file. Imp, JSON, and indexes.
I want to see
So
what you're doing with graph.
I can like search. So I could do it with no filters and search through the nodes, and you just get like here are the nodes that match. So you can search by
Like a complete execution history, more or less.
Yeah. So I'm gonna search for nodes that contain 1.123 in their input. So you can see like these have the substring 123 in the text form of their input. So it does store them in the like binary form,
Okay.
kind of.
You're not showing a graph view. You have a graph you are showing slices of.
This is a node in the graph, so you can see like the connections. Like the connections are dependencies and dependents. So you can see like this is the range sum.
Yeah. If I bring up a node in Sea of Nodes in the debugger, IntelliJ debugger, I'll have inputs. Okay. Inputs and outputs. That'll be a list of things, just what you got here. And I was hoping to see an actual graph.
It is. I mean, it's a graph. This is a node in the graph. So range sum.
No, I meant a two-dimensional layout, a planar two-dimensional view of a graph.
Yeah, graphical graph.
No. So that would be difficult because if I search this, you could see that there are
right. No. So you don't sort of the whole graph.
3,601 3,601 nodes in this graph.
Right. No. This, I mean, I've been in this path before. You get a big compiler graph. So you have an execution graph can get really big. I've certainly had compiler graphs where I've had 100,000 nodes, and then try to display them. But I'll limit myself to say a few hundred nodes on the screen, and then the rest is off screen, and then there's some scrolling and panning and zooming and shit you do. And it's entertaining. I was trying to see how far you got. And the answer was you didn't do any graph layout things. You have an execution graph and an explorer for an execution graph.
Yeah, and then I could go to like the Fibonacci ones. These have messages in them, so like a node can like log stuff.
Sure.
Yeah, and then you can go through. You get search, and that's the new thing. History, and then back and forwards.
Yep.
So I can be like, okay, there's 31 nodes in this graph. This one's way smaller.
Yeah.
So, and I'll probably add like something to search through debug messages as well. But yeah, that's that. And
now use this in a useful way. Debug a real problem with it.
That is what I will be doing. Hopefully by next week, we'll see this integrated into the actual compiler, and instead of being like, okay, what's the Fibonacci number? It'll be like, what's the size of a class? And then you have real information that's actually useful.
Yeah, you have a different layout for your IR bits there, but yeah.
Yeah.
I
So
have that information somewhere in the graph shows up.
So I can actually, let me share again here real quick. I'll go show how this is going to be integrated real quick. I'll just share my screen. So the compiler is going to be kind of a similar thing. So it just requires that the function have like a string. So I think I've probably shown this a little bit before, but I can pick one of these like resolver functions. And these like wait, I'm in the header files. Where's my CPP files? Okay, so like you have, this is like the query. So this is the old implementation, not the new one that I've been working on. This one uses like a bunch of macros and stuff. The new one is a little different.
Well, we can't
So
read either one. So what's the point of them? What's the deal?
so you have like queries, input, output, and then they are memoized so that you only calculate them once. So like if I go here, you can see it's got like codep and lookup or like function primitive. So this is like looking for built-in function information for like, okay, what's the return type of a functionoid? And that's kind of like related to a function, but because there's function overloading, a functionoid is like a specific overloaded instantiation of a function.
Okay. Yeah.
And then function primitive is like, okay, this is a built-in function or not a built-in function. So like int 32 add or something, it's going to check for that with this. These, like anything that turns into an IR instruction instead of a function call is going to be returned by like this function primitive thing. So anyway, this is like memoized, right? So like it calculates it once and then it's not going to calculate it again. So it's doing a lookup and then it will kick off the node execution if that has not already been calculated. So it's
Gotcha.
not.
Yeah, this is
So,
your lazy evaluation of your IR bits and pieces. Yeah, you have a different slice on how to do these things than I do by a fair
I
amount.
mean, I don't know if these are IR. Like IR would be like was it like instruction? Is it this one? No, that's the old one, I think. No, actually, this is the right one. Oh yeah, so this is like the IR, which is like VM instruction, and then there's like functionoid routine 3, because I had two other versions. This is the current one. I should probably drop the 3 from it at some point since I deleted the others. But you have like your local types, your parameters, you have executable blocks, and then you have block names. That's just basically like debugging information. And then you have non-trivial destructors, which is just a reference to like, okay, this type, you need to call this destructor. And it's like executable block has like entry state, instructions, and then a terminator instruction, which is like
Right.
different
I
than
mean,
regular
this
instruction.
is IR descriptions. It's
Yeah.
not what you're doing with your graph.
Yeah. So the graph would just be like for example, function what's it, VM procedure. Uh, 3. Okay, so it calls this, it's like, okay, is it built in or is it a user function? And then we have this user VM procedure thing. And this is what actually like generates the VM procedure. So we have this VMIR generator, takes a binder, and then it calls this coroutine, which is doing kind of the same thing as before, but it's a class that has a bunch of functions that it's calling
All right.
recursively to generate the IR.
Yeah. I'm not able to follow cleanly, so we have to figure out how to get presentation on what you're trying to accomplish here.
Okay, so this is just like it's calling a function, which is like, so the input is going to be the name of the function, and then the output is an object that contains the IR, and that gets cached by because this is like a query essentially.
Right. And we have to up level somewhere in here as to why you went down this path over any other. Like the things you're pulling out of your queries, I have directly, and I never bothered to cache them, or they're only ever cached or something. There's no compute for it state.
So the reason I did it this way is because when I was looking at C++ and like why it would take so long to compile, what I realized is that most of the time was spent like you have many different translation units, and many of them were like recompiling the same headers or the same functions over and over and over, rather than there's a lot of duplicated work between different invocations of the compiler binary. So my thought was, what if instead of having a bunch of separate compiler executions, we just have one compiler execution and it strongly caches everything so that it'll compile all these functions, but it's using very, very aggressive caching where it only calculates almost everything one time. and then it just persists everything in RAM for the whole process. Because actually, I realized that it actually, I think, uses more RAM when you have like 50 compiler bodies running.
Yeah. Oh, we lost your video.
At the same time, and they all have duplicate or lexing the same file over and over in different processes.
Yeah, I disagree with that being slow. I completely disagree.
Things here.
It's not slow. It uses a lot of RAM, and it's very duplicative.
Yeah, there are.
I guess it is slow actually, but because like templates get compiled, like I had one template that was compiled 182 times in my like small to medium size. Like this is a maybe medium sized project, right? It's not a large project with like 3 million lines of code. It's like 60,000 lines of code or something, or like 30,000 lines. So it's not that much code in my project. And I had a function 182 times. It was compiled.
Yeah, I'm gonna grab a link. I can't put in the docs because I don't get that email anymore. But
oh, if you want the email, tell me. I sent out an invite for the email for the docs. Google made me switch over to using Google Groups. So you get it from Google Groups, not from me.
You know what? I seen that once, and maybe I just didn't. Maybe I just thought I was
if you need
subscribed already.
So you need another invite. I can invite you again.
Okay, but I'll just paste the link here for you guys to add in the docs. But I once measured the C++ and C's compile time. I actually don't remember if I did both or one, but
which compiler?
Both GCC and Clang, and TCC just smoked both of those. So
honestly, I think the problem, like individually, like if you compile a small file, C++ is not that bad. The problem with C++ isn't the time it takes to compile a function. The problem with C++ is that you have a header file that's included by 500 translation units, and it recompiles that same header file in all the translation units.
No, that's not. Problem. It's not slow. That's not slow. You know what's actually slow?
That is slow.
When you have an inline function or a template in the header, the code gen for that function is slow. Yeah. If it's one line, 2 lines, it's fine. But if it's like 50 lines plus, that gets really slow. I have a webpage for that, and
that's what I was talking about. That's exactly what I was talking about. Is where you have
the last project I was on, people included 100 headers every file.
Yeah.
And nested headers included nested other things. So yeah,
if you have a million enums, it's still going to be fast. Like I don't remember the numbers, but everything is fast except for the function body.
Are we modules yet? Oh, modules for the greatest things.
I'm not touching modules ever.
Modules are a partial solution, but they don't. It's not 100% fix, because. But yeah, I see what you're saying. But yeah, it is the functions, it is the templates that are slow. And so my thought was, I don't want to remove the flexibility that having the templates provides. So I have like 10,000 lines of header files, but the problem is that they're compiled again and again and again and again in every translation unit. So my thought was, okay, I want to keep this flexibility, but just compile each template with each set of arguments one time. So just cache it, and then do that for don't compile each file in separate processes. Just have one multi-threaded process that compiles all the files together with multiple threads, and then the threads can synchronize with mutexes on locks.
Wait, this is starting to smell more and more like Gradle.
It's a single process.
Bazel.
Bazel? You think it's Bazel? Bazel is Gradle for C++.
Bazel launches a lot of subprocess, doesn't it?
You guys might remember my C++ thing from like a few weeks back. That big header file, it's a couple thousand lines of code. It compiles like 200 milliseconds. It's insanely fast.
Yeah, but the thing is, every little header that takes 200 milliseconds to compile, when you have 400 source files that include the same header file, it starts multiplying, right? That's the problem. Is that if you have when you have one file, one header,
if you
one
have
source,
a lot of files, yeah,
that's the problem with C++. It's one file, one header, one source file, no problem. 2 headers, 2 source files, not really a problem. 200 headers, 200 source files. Now you start getting this O of n squared problem that
but doesn't
C++
it
has.
Wouldn't it compile it and store it as a binary something
No.
something somewhere for the next
No.
import.
That's
No.
what, yeah, that's my experience as well. So
If you-
way more than 200
Well,
in all directions. And yeah,
well,
the n squared, I guess it's n squared. Compile times were ludicrous. Bad.
so Cliff here works with people that develop the LLVM compiler. What's their solution like? I'm just kidding,
Their
but
solution is to wait.
LLVM takes a long time to compile. What are you talking about?
Yeah, their
I
solution is to
compile
wait,
LLVM.
Levo.
just the wait.
Yeah, the
Yeah,
development time was crazy.
their solution is
I
buy a
could not see,
Threadripper.
and I was watching other people not get the kind of turnaround times that I had 25 years ago. And certainly when I go to Java, even a big Java, if I get rid of Gradle out of a Java project, fucking Gradle, then I'll get turnaround times that are in the milliseconds. Like I can't go to the next syntax error in Emacs faster than I can just hit the compile and pop me to the next syntax error button to recompile every time. It's just too fast. Whereas at the project I was at not that long ago, it was 10 minutes for anything. If you had the right optimizations and the right caching done, and
I bet that was the build infrastructure, not the
yeah,
compiler. Like
but
Bazel, Gradle, all those things are just like
yeah, Gradle will do it
destroy
too.
the world.
But when I got down to one thing to compile, the time for a file was still on the order of 30 seconds for a file, which was some thousands of lines of text, plus his 200 include files, which brought in the next million lines, and it was still, a big number. And if I
Even
went
just
debug mode, it was twice as fast to compile and generate the code. The code was 10x slower, and then the time to get to the bug was then at 10x longer. And it's just nightmare to go try and debug things.
I
So
think
that
somebody
was
on
C++
the Chrome,
shooting itself in the foot.
I think someone on the Chrome team was saying that they have like Incredibuild and whatever other build solutions where when you only edit one file, it's actually like 5 seconds or 10 seconds.
so incremental compilations are a thing in C++, and they work pretty well as long as you don't put templates in headers. That's the problem with C++. As soon as you start using templates and putting them in header files, it's super slow.
Are templates that aren't in headers useful?
Yeah, right, exactly.
Not particularly.
That's a good point. Templates are always in headers.
Almost.
Right,
I mean, you can technically
Yeah, but like,
extern your templates.
Let's back up a bit here and summarize as C++ is difficult to make a fast, complete development environment in a large scale. And is that like not negative? No one has a complaint with that statement? Then we can say, okay, we can be done here. Actually, yeah, I got a little bit.
So that's why I'm changing how the compiler works. I'm saying,
yeah, right. Okay. I would have approached that problem in an entirely different way. I have approached that problem, but not for C++, in entirely different ways. And and maybe I can't say one is better than worse than the other, especially since I'm not doing a C++ one. Fine. I'm always surprised to see you've talked about this before, and I'm kind of surprised where you got there.
But I want to be able to take a project the size of LLVM and compile it in a minute. That's kind of my goal with this language.
Right.
That's why I structured it the way I have.
Totally, and some other world that's possible, but not in the current way C++ is typically coded as.
Yeah, and so I've structured my language around this idea of like aggressive caching, and it's actually going to make it slower for small projects because map inserts and deletions are not free, right? That's extra overhead. But when you have like deeply enough templatized, like Koja is really expensive. So when you don't have to regen those functions, that is going to be faster.
Here is a Matt let me hit the share button. Okay. Can I?
I want to ask about bulk inserts into a hash map later. Yeah. But right now, quickly, I suspect that Autodesk, Adobe, and whatever companies that use C++ would rather switch off of C++ than pay for a compiler that's actually fast.
Oh, that's hard for me to say. The problem with a compiler is actually fast, quote unquote, is that it has to actually be completely a C++ compiler all the way down the line for these big projects, so they won't be plug and play compatible.
I suspect having a standard C++ compiler will get no sales, but if it's compatible with Clang and GCC, it would be usable, but I don't think a single person would actually pay for it, like a single company. They would just rather have everyone wait 15 minutes.
Yeah.
And doing the type of optimizations you want to do, but doing them for Clang is not an option? Or it's just
That's
not
more
fun?
doing it for Clang was like I viewed that as more difficult than writing a new language. And also there are other things I wanted to fix with C++. That wasn't the only thing. So it's like,
Yeah. I'll be right back.
Because like Clang
He
is the
can't
big
commit now. You use the be right back thing. Sorry.
Yeah. Okay. Oh, Matt, I can't keep up with you. Throw these things in the links, of course. Yeah, I mean, I was using Bazel, this other project, and I claim it was not fast.
Bazel is just it's like a meta build system. Like,
Right.
well, not, I don't know, meta build system is the right word, but like it's a compiler launcher. It's not really the compiler. It's the thing that like
it's the thing that slows down the compiler.
Yes.
It's the thing that launches the compiler for different like executables and stuff, which is
it spends a lot of time thinking about what it should eventually do. And then finally, once it's come up with the most optimal plan for compiling the one line you changed, it will then start and compile it on a remote server.
That was my experience.
It's just
the turnaround time for Bazel was really gruesome. And if you had learned all the ins and outs, you would figure out when you could sidestep Bazel and when you couldn't and get away with it.
And the thing that gets me with it is like I change one file, like I'm in Java, I change the body of one method somewhere, and it's like, oh man, a lot of things use that class. I'm going to recompile everything.
That's great.
I mean, they're all of them, but like I've been hitting that with Bazel constantly. It's like I changed a line, and you're going to recompile the universe.
Can you change a comment and have it recompile the universe?
I think unfortunately Bazel is smart enough that it would realize no, for that it doesn't need to recompile the universe, but it'll have to think really hard to realize that.
Yes. Okay, fine. Whereas the time to actually compile the one file would have been faster than the Bazel think time.
Yeah.
They just didn't have Bazel in the loop in the first place.
That's interesting.
Fine. I have to. This is another deep go read, and I threw up the Bolin piece of Levo's back, but it didn't have numbers on it. I wanted to see. Here's code. Repeat. How fast? Oh, you have to click. Oh, you got it hidden. I have to click through. Why are you hiding this from me?
Because I didn't want to spoil people when they just want the text in the middle of the page. But if the text is in the middle of the page, the numbers would show up. So I wanted it to just be hidden. You can press S to also show it.
Okay. So this is compile times for one item or in the class.
It takes a while to go through, and I was just assuming people would just like use it as like a reference.
Okay, I have to go think my way through to see what you're actually saying here, but it's actually more time than I would have suspected, all to do with, I would claim, how you the complexities of C++ processing. Why would this make any difference? These characters here in an enum, right? I mean, okay, so you had to parse it, you had to realize that you made a new enum, you had to go decide to add a member to the enum collection. These things should all be done in low microseconds.
Yeah, so if I have
much bigger.
So this first one, it's 250,000 of each of these.
Yeah.
And I just want to like see, is it slow? Is it not?
Oh, you didn't repeat it 256,000 times in a loop. You made a giant single file, for instance, with 250,000.
Okay. Yes, yeah.
Yeah.
Okay. But the enum was faster than the struct and class. And I thought all three would be the same. But I guess it does make sense that the struct and class
would be... then. Yeah, okay.
Yeah.
But they have different implementations. Like Java enums are, in fact, a struct, and there is no struct or class variation different. So they would be the same for Java because they would just go to the same backend. You're compiling to, like, when I say Java, it'd be Java C times, which don't get down to machine code generation.
Yeah.
Here you're probably already timing till you get a .o file out.
I feel like this is not a very fair thing to test how the compilation is, because at this point you're just
testing. It's a useful point if you decide that it's if you recognize the limitations, right? You repeat the same thing over and over and over again. You're testing some very narrow subject about how compile time goes or where compile time goes.
Right, but if you don't...
When I wrote my standard library, I actually looked back on this just to see what was slow again, because I didn't remember. The only thing I did remember was that function bodies were slow. But what I didn't realize until I wrote this page was template bodies, if it's just like a line or two, is actually really fast. Like as fast as like an inline function that's only like a non-templatized inline function that's only a line or two. So I'm like, okay, I'm comfortable with templates being my standard library, and yeah, it compiles quick.
Yeah, that's an observation you put in here. Sorry. Classes are slower and likely have methods. Classes almost surely bring in a bunch of default methods.
The slow thing about templates is not that they take longer to compile than a regular function. The slow thing about templates is that you put them in a header file, which means they're essentially an inline function. And that is the reason why that's slow isn't because it actually takes a long time to compile the template in any particular reason. The reason it's slow is because you have 4,000 templates, and then you have 4,000 source files that all include those 4,000 templates, and then now it's 4,000 times 4,000 because each of those templates is being compiled again by all the 4,000. Like there's duplicates. That's the reason it's slow. It's not because it takes a long time.
Right, even for the same T.
Yeah. And so this is where Bazel may be not caching because they're doing it to coarser granularity where you're trying to cache here.
Yeah, I suspect one of the problems with the templates is instead of using an overload instead of int16 using int, it would just if it's a template, it would just recreate a template using like shorts instead of int. And I think just like accidentally having a lot of functions instead of doing a cast actually makes it slow.
It actually doesn't matter because even if you like have the same template and you use the same arguments, if you're in different translation units, the C++ compilers will recompile the same template with the same arguments as you did in a different translation unit, and they don't get deduplicated until link time.
About to say, because the linker will deduplicate them. Yes. Okay. Yeah, I was asking actually. The linker does deduplicate them. I think it should.
Yes, it does. The linker deduplicates
you went ahead
them.
And made them all, and that's the compile time. That's an
one of my pre-commit hooks is I have a Unity file that includes all my source files, and in my commit hook I do a syntax only check on my Unity file, which includes all the source file, which means it checks everything just for syntax. And if there's a compile error, it'll just like pick it up. So I do that first before I try to build, and because when I build, I'll run the test, but I want to check GCC with GUI and no GUI just to see if everything works, and then Clang with GUI and no GUI or headless. So yeah, Unity and Unity builds with syntax only works really great as a syntax check. I mean, a git commit hook. Yeah. I have like a lot of small little tricks that I have all over the place. They're very handy.
The problem with Unity builds though is that if you have translation units, you don't get the benefits of incremental compilation.
Yeah.
All right, done.
Yeah.
Which, may or may not be worth it depending on how many headers you have.
I'm not there right now. I'm going to go do my Java C thing and moan about Gradle and decide, do I want to burn a bunch of time sidestepping Gradle again, which I've done a couple projects, make life go faster for everybody.
I wanted to touch my build system again, but I'm not ready to commit a bunch of time to it, so I haven't really started. But there's a few things I wanted to change, and I feel like I'm always going to find something that I've like overlooked and gonna want to add to the build system. So I think I should just avoid it until I get like a really big idea that I need to do or that I want to do.
Got to get well, so Hashgraph really is on the edge of trying to decide. There's a wide agreement that no one likes Gradle, and also there are no good alternatives. And in my head, a custom build is a reasonable alternative, and there should be a better alternative than Gradle. But like Maven wants XML everywhere. That seems pretty gross. And there's a couple other guys who have other things that have issues in how they declare large projects. But I've done large projects repeatedly in the past without any of these tools, and there are definitely ways to do them better. But you have to have some, I don't want to say skills, you have to some discipline.
I noticed AI plus make files are actually pretty decent.
Oh, AI in Makefiles. Like Makefiles have issues with discipline, and they have syntax that's weird. It's old and it's weird, but
Oh,
it's not bad. It's just weird.
100%. Yeah.
But I haven't tried using an AI to upgrade the makes. I just use discipline. So that's interesting. I might try AI on Makefiles. They probably can do something good.
CMake is available. It exists and solves the problem with C++ for the most part.
Yeah.
But why is Bazel being used then? Because Bazel's solving the problem of a large team of people who are doing their same builds repeatedly, which is weird because in my head that was solved a long time ago with like Ccache was like the company-wide thing. If you had the same source inputs, you got the same binary out, and we skipped a hashing step. Gosh, I don't know. Fine.
Well, Ccache was like it actually it tries its best not to change the output of it's mostly just reusing rather than trying to like prevent it. Also, Ccache had some issues.
Matt, what is I'm switching briefly here. Matt, what is the common package specification? Why is this link here?
Just came out, and it's from Kitware, and Kitware is pretty much the CMake company. And what's interesting is that it's actually going to enable non-CMake projects to use CMake-like features. It may be a way to migrate away from CMake in the future, which is interesting because it's coming from CMake people, essentially.
Mm-hmm.
It does simplify, even if you stay in the CMake ecosystem, it does simplify some common packaging things that everyone had their own solution for within the CMake ecosystem. Now it's more of a common specification, so maybe not everyone is going to reinvent it. We'll see. But it just came out like yesterday.
Okay. I would have to go stare at it now, make sure I understand what I'm looking at. No. Okay, fine.
CMake itself is just a meta build system, right? It's something that runs the commands that may eventually run that actual build system, but that's not necessarily giving you anything about packaging and dependency management, and that's that layer, one could say, on top. Like if you have a library that depends on Qt, how do you find Qt? If you have library that depends on networking library, how do you find that networking library? How do you package to express this dependency? So it's supposed to solve that level of problems. And people were abusing, one could say using or one could say abusing CMake for this packaging and package specification, but that was never really a good language for that.
Well, I think people abuse Gradle plenty. Abusing your build system for fun and profit. And then the lead engineer, whose all life got soaked into keep maintaining the Gradle build, got pissed because he wasn't actually engineering any code. So they leave. Then you have an abandoned Gradle build project. And this is the state of affairs of several companies I've been at. The build system, specifically Gradle as a build, I don't know about others, will eat an engineer, a good one, full time, and then they get pissed because all they're doing is the build and they want to do something real. So they walk away. And then you have
That's why I never touch the build system.
Yes, exactly.
Yeah.
I have and
I only complain about it.
The first step is to delete Gradle.
Yeah.
See, but at that point you touch the build system. It's just somebody else's problem.
Yeah.
I think Maven is tolerable without its
XML. Maven's a tolerable one?
Yeah.
Okay. I don't know. I have very specific and I want to say very weak requirements, very simple requirements for a build system that none of the build tools ever pull out, and they can't make it. And I'm just like confused as to why people can't see this as the obvious thing.
Then it's too low level. And it's too low level then.
It's great. I love it.
Okay.
Cliff, if you can explain them within 2 minutes, I'll listen. I'm not going to touch it for a while. Could you explain it in less than 2 minutes?
Yeah, and the answer is, of course, I'm missing big pieces, but maybe I'm not really. It's always the issue that I want to know the build I'm looking at is the mapping between some set of sources and some set of outputs. and those are all turned into files specifically, and the file system gives you hard atomicity guarantees, which is all you need. And people who do things with tasks like Gradle don't get those atomicity guarantees, so they get fucked up, and I get Gradle fuck up on me all the time. And I need a mapping from source to outputs with a tool that will do that. I need to have enforcement that you don't get unnamed outputs that become accidental inputs. That's actually pretty easy to guarantee that people, I don't see it happen. People accidentally leave crap lying around that they've sucked into the next pass, except there's a hidden state that's not visible to the build, so people get mad. So there's an easy fix to say your build tool step cannot read anything that's not mentioned and cannot write anything that's not mentioned. And an easy one for that one is said if you're going to write some shit out and it's more than one obvious thing, you're going to get a temporary subdirectory. And if the build went correctly, we're going to pull out of the directory what we wanted and everything else we're going to nuke. And therefore you can't accidentally leave tidbits lying around that you depend on for the next pass.
Those are good.
I'm missing the dependencies, except the dependencies are all things that in my head belong as a set of inputs that you wrote down somewhere. I need the following things. It's just an easy, it's another dependencies like between a header file and a .o and a C file and .o. Those are dependencies you write directly with the build step that says, I get a .o from a .c and a .header. The dependencies are another one. I got the file from Maven of this version number, and I have some dependency list somewhere. And then I'm going to pull down from Maven. So that's always been part of these systems, but it's never been a big part or something. It's not a hard part. I certainly do this in Make all the time. I have my dependency list in Makefile. And first step, he runs to the internet and grabs shit. Oh, that's another piece. I want you not to touch the internet unless you specifically say so on the build line. No accidental touching of the internet because often enough the internet for me is not available. And if you touch the internet and it's not available, you hang, you go slow, the build breaks, says something stupid. You should not need to touch the internet to do 99% of my edited a file and I want to, compile. The output of the build should at most produce one line per file produced. Tasks that run successfully, like Gradle does all the time, should not report success because they're just done. I mean, if they're already done, they didn't actually run, they're just done. They should. Gradle says, "Hey, this is up to date. That's up to date." And then 500,000 lines of "I'm up to date." Later, I can't find my bug buried in the "I'm up to date." Don't fucking tell me you're up to date. So, pretty straightforward stuff. I've done this to different projects as well and had it work well for a bunch of people. So, remote distributed scale out should all work, but transparently, usually by the file system giving you atomicity guarantees, it's all fine. Shared caching for multiple people hacking. If you pay attention to how the file system works, you can make that work sort of straightforwardly. Right now, for instance, if I have Gradle running, I've done a build in a window, and I bring up IntelliJ, he immediately launches Gradle behind my back. And now I have two Gradles running on the same build setup, and they confuse each other. And then they both break, and neither one works. And I have to clean them both out and start them both over separately and one for the other. Fucking what the hell not? Why can't you work here? I don't know. So I'm whining now. These are all things I've solved in the past. Bunch of stuff that Gradle tries to provide for me are things that I never care for and that I don't really want, especially when I'm doing my development cycle. I want it a fast. I touched one file, touched one line, it built the one thing, and the debugger can run again immediately. And by default, Gradle will try to push me up into a jar file and then tell everyone, go read the jar file. But that was just a copy of the class into a big zip and then an unzip to go debug. And don't bother with that. And you can't, well, you can. You have to screw around and get around it. It's not a thing I want. When I want a release product, I want a series of jars put in a directory, and maybe then they're tarred up or whatever as a here's a release object to go take and pack and unpack. That's a great thing for a build system to do, but it's not on the path that I do when I do development work. And so it needs to be separable. I want a release and I want a debuggable thing. And that's a clear piece of what I want out of a build system.
I'm going to have to listen to this again when the video comes out and write these down. The closest thing I have to anything that you just said was I actually have an option where it will spit out the files that were modified and it will say that this file was built not because the source file was changed, but because one of the headers were changed.
Right.
And I ingest that in my program to figure out which test to run.
Yeah.
Now, whenever I modify a file, it will run only the relevant test. It's so good.
So you think Bazel does that too, and the definition of relevance stretches well beyond that.
Right. That's what I don't get about these things. So I certainly have done this build things where I ask the build step what header files got included for both Java and C, and then included them in the build process thinking so that the next go round, if something changed in the headers, he does the right thing. That's not hard to do. And I go to Bazel and like, yeah, as you say, you edit a line in the middle of nowhere and every fucking thing on the planet, same for Gradle, has compiled. And why? There's a giant mystery of where who depends on who, what. So I guess there's a transparency I'm used to that I'm not getting out of Gradle or Bazel that lets me understand why a thing had to be built in order to even discover what was kept building, and then why did you have to be built? Because I would have thought if I hacked this one line, you would have done this other one line. My .o changes, and then I'm going to fire up the debugger with a pile of .os. That's not what's happening. So why not? So there's a transparency. The rules and the transparency are a file through some step produces a file. And so if there are multiple inputs and some multiple outputs, okay, there are, but there's some inputs that are files, a process, and some inputs, some outputs that are files. That's the rules. So if you wanted to tell me why something had to be built, I touched this and this got built, there has to be a chain of this file, process, this file, process, this file, however long I got to the end. And that's what I'm not getting out of Gradle or Bazel.
Yeah.
They'll just like, for reasons that make no sense, we're going to compile universe. And it could have been, bad build steps. The build step says, I build because I depend on, say, the current nanotime. And the nanotime changed, so I build again. And 100% builds every time. And stupidly, you get a build step that says, I always work, I always do work, I always produce a new output. And so, things are screwed downwind of this. And maybe that's what's happening accidentally in some of these tools. Somebody not realizing it has arranged a build step that always fails the I'm up to date step.
Mm.
I'm trying to diagnose my memories of why Gradles and Bazels have failed and built ludicrous counts of things in the past. The transparency is not there. They voluminously puke out stuff that's unrelated. That I successfully did a million things. So don't tell me you fucking successfully. I don't want to hear that. Tell me what you failed. And okay, fine. I certainly have done build systems myself I've been happy with.
The one
And
place
they're
where I
fast and
argue with
quick, and
the
you
only
can
tell me if you failed,
I'm sorry?
the one place where I argue with the only tell me if you failed is I kind of like having the progress bar that keeps erasing the one
Yep.
line and
Yep.
rewriting that one line that's like,
I'm
I've done
I'm
15 of 1500. I've done
right.
16 of 1500.
Right. I'm okay with the one line per file produced kind of thing on that kind of a report so that you can see some progress and also you can get a listing of what was changed. If I do it in Emacs where he has a dumb terminal window that doesn't do the rewrite, you get the list of all the files that are changed. And I find that convenient. Sometimes it lets me know it's big or small or whatever. And I have shortcut printing versions for that to say, I've changed one file plus, this file plus 257 more, and then
Yeah.
get the full dump if you ask for it.
The one thing that bugs me with that is the rewriting when you're piping it to a file because it's happening in some build process somewhere.
Yeah.
The file gets really long because the carriage returns are just
Yeah.
characters. It's not actually backspacing.
I get those files, and they're hard to read they're just hard to read because they're full of ASCII control characters that are being not interpolated.
So I do sometimes pollute my output to log files when I'm trying to give a progress bar to people who are there live.
So the thing here is that I want a progress of a file that got produced. And what I get out of Gradle is a progress of him inspecting the universe. but I know for a fact that my make system can inspect the file system at millions of files a second. Like the stat time on a file is like nothing in any reasonable OS. So why does it take gradle 20, 30 seconds to decide that it's ready to do something? Mark, you were just talking about it with Basil, same thing. It took forever for him to deeply think the universe out. And like, no, this is like instantaneous, dudes. What the fuck's going on that you're so slow about it? I don't need a report of you inspected a file and saw it was up to date because it's instantaneous. It takes, it's microseconds at best for the stat calls that are all cached easily. And you statted a few things, you got a couple microseconds, and you decide you're up to date, and a couple microseconds later you're done. And why did you try to tell me something that took microseconds? Oh, it took you seconds instead of microseconds. I'm like, where's the million X slowdown, dude? What the hell? Fine. I'm whining now. And Mark's smiling at me, and well, you should be.
Yeah, I mean, it's build systems. They're all there is to do is whine.
I don't know a single person that likes a build system.
Fine. All right. Having said all that, I am going to break shortly because I have to be on the road in an hour. I'm going to have my lunch and be casual for a minute to go to the courthouse.
Guilty.
To make the society that we live in hold together another day.
Oh, you have jury duty?
I'm on jury duty. I'm actually a juror. I'm not even getting picked. I've passed the picked. I'm on jury. And next week, I can tell you all about it, but I can say, safe to say here that mistakes were made. And no one got hurt, thank God. But wow. All right.
Interesting.
That's it. Is there anything else? Last minute words?
Well, if you guys really want to talk about hash maps, I can ask how about bulk inserts. I noticed
bulk inserts is a great topic for hash maps next week.
Next week, okay. Yeah, because I figure with algorithms, this club will like to talk more than 20 minutes.
Yeah, right. Exactly. There's
an
easy answer, 4i equals to many insert, and there's a hard answer, which is next week. All right. Bye-bye.